All right. So we're asked to find the x-intercepts and y-intercepts. We have to circle the x-intercepts and box the y-intercepts. So first things first, x-intercept sounds a lot like x-intersects, right? And y-intercept sounds a lot like y-intersects, right? So when you're looking for the x-intercept, you're looking for where the graph does what? I'm looking for the x-intercept. I'm looking for where the graph...
Where the line intersects the graph.
What line? Okay. So I'm looking for the x-intercept. I'm looking for where the graph crosses which axis? The x-axis.
See, I did explain
I'm looking for where the graph intersects the x-axis. Does that make sense? All right, so
it was supposed to be.
where does graph number 1 intersect the x-axis?
Oh,
Okay.
0 foot.
Right there. What's the point? What's the point?
4 0.
4, 0. 4, 0. Okay. Where does graph 2 intersect the x-axis? 1 and -2. Okay. So this point is -2, 0. And this point is 1, 0. Where does graph 3 intersect?
1.8.
1.8? It's right there, right? Actually, 1.5.
See, I was thinking that, but it looked too over to be.
Gotcha. The grid lines didn't come through as well as they should have. If you look up here, there you can see this little grid line. It's a halfway grid line. Actually, a quarter of the way grid line. Quarter of 2 is 1 there. All right. So does that make sense? Okay. So I circled all my x-intercepts and I wrote down the points. So hopefully on your worksheet, you circled all the x-intercepts and you wrote those points down. Right? Does that make sense?
Yes.
Okay. So the x-intercept then, I'm going to write down some notes because we have to write a little bit of notes down. The x-intercept is where the graph does what? Good. Where the graph intersects. Okay, synonym for intersects is crosses, right? Intersects the x-axis, right? Where the graph intersects the x-axis. Now there's something interesting about all of these points. Okay? All the points that we wrote down. What's interesting about every one of those points? What's the same about every one of those points?
0.
What's 0? The y. Okay? Jamira, when we find the x-intercept, that means that our y value is 0. So the x-intercept occurs when y equals 0. Okay? Because when we're on the x-axis, do we have a height? No. Okay. I guess on your notes you already have a nice picture. Okay. If you're taking notes on line paper, which you don't have to if you don't want to. All right. This line right here, that spot right there, that's our x-intercept. Right? It has no height, does it? It's right on the x-axis. So right on the x-axis means y is 0. That means every x-intercept will follow the pattern of x, comma, 0. Every x-intercept, when you find the ordered pair, will follow the pattern of x, comma, 0. Okay. Does that make sense? Yeah? Are there any questions? Any questions? Anybody? All right, let's find our y-intercepts now. Okay. So, y-intercepts. Where are the y-intercepts? Where we do what? They're on the y-axis, right? It's where the line does what? Crosses it. So the y-intercepts are all found on the y-axis, and it's where the line crosses the y-axis. Okay? So the y-intercepts we're supposed to box. So that's the one for number 1. What's that value?
0.4.
0.4. Number 2, where's graph 2's? Down here, right? What's that order pair?
0,
And graph 3. Down there, right? What's that order pair? 0, 3. Yeah, negative, thank you. Now, real quick, before we go on and write some notes for y-intercepts, every graph up here has how many y-intercepts? 1. Okay? Any graph will only ever have one y-intercept. And we'll learn why later. Right? But every graph only has one y-intercept. Okay? Because the y-axis is a vertical line, and a graph can only intersect a vertical line once. Okay? We'll get into why later. Now, how many x-intercepts can they have? 1 and 3 have how many x-intercepts? 1 and 3 have how many x-intercepts? 1 each, right? 2 has how many x-intercepts? 2. Okay. There could be a graph that had to have 3 x-intercepts. Remember we talked about x cubed functions? They look like an S, right? Well, when you start doing things besides just x cubed, you can end up getting an S that looks like this. How many x-intercepts would that have?
4. No,
3. Right? 1, 2,
Can't
3.
count.
Okay, that's all right. Counting's not necessary for math. All right, what? Can you flip it over? No, because it intersects the y more than once. And we'll get into why that doesn't happen later on. Okay? All right, so you can have as many x-intercepts as actually comes down to what kind of power you have. All right? If I have a line, what's the power of the line? X to the first power, right? Mx plus b, isn't it? Right? If I have a parabola, what's the power on x? You guys remember this from last year? 2, right? It's x squared, 2 intercepts, 2 x-intercepts. If I have x cubed, x to the third, how many x-intercepts do you think I'll have? 3. X to the fourth, how many?
4.
4. It's kind of, it increases that way. It's kind of, math is kind of nice that way sometimes, right? So x-intercepts, you can have as many as you have powers. Y-intercepts, you can only have 1. Okay. Now, is it possible to have a line that doesn't have an x-intercept? No, it's going to, right? It goes in both directions, unending. Same slope the whole time, right? So every line will always have an x-intercept. Okay? You might not see it in your graph on your window. Okay, you might not see it in your calculator, but it does have an x-intercept. What about parabola? Is a parabola guaranteed to have an x-intercept? Is a parabola guaranteed to have an x-intercept? If this turning point is up here, will that have an x-intercept? Okay. If I take this parabola and I move it and I translate the whole thing up 5 units, all right, it'll look like this. Will that be an x-intercept there?
No.
No. Okay. So as you start getting functions that have powers like squared, cubed, to the fourth, to the fifth, it's possible you don't have an x-intercept. All right. Before we get into that fun stuff later on this unit, we need to first figure out how we can find these x-intercepts in y-intercepts. Before that, we got to finish up our y-intercept notes. Didn't have myself. Sorry about that. All right. So y-intercept. What's something you notice about all the y-intercepts? What is that, Bruno? X is 0. Okay? So in all the y-intercepts, it's where the graph intersects the y-axis. And what do we know about this place? X is 0. Okay? It's this spot right here. Right? We haven't slid left or right at all, have we? It's right on that vertical line called the y-axis. Every point that's a y-intercept will have an ordered pair that looks like what? 0, comma, y. Whatever the y-intercept is, that'll be the y. Are there any questions about x-intercepts and y-intercepts? Kind of definitions. Any questions? Think you learned this before? Yeah, good. That's why reviews are nice. It gives you guys something to build off of. Okay. All right. Let's go to example 1 then. All right, example 1. We have 4 equations, and there are 4 equations shown. Some of you getting excited, huh? We're going to do some algebra here. 4 equations are shown below. Use algebra to find the x and y intercept for each equation. All right, now you guys have these equations on your paper, don't you?
Yeah.
Yeah, who likes algebra? Me. Yeah, me too. Algebra's fun. Now, we are going to take advantage of what we know about the x and y intercepts to figure out the x and y intercepts for this equation without graphing. All right? I made it look like this because I didn't want you to just jump it, just take the equation, plug in your calculator, and find them that way. All right, I know you know how to use a graph. We just did. Right? I want to find them without using the graph. Okay? So, for A, we have 3x plus 2 equals y. All right, so this is A. Now I need to find 2 things. I need to find the x-intercept and the y-intercept, right? I need to find the x-intercept and the y-intercept, correct? Okay. So we need to find the x-intercept and the y-intercept. Now in order to find the x-intercept, what value do I already know? What's 0? The y is 0. If you're finding the x-intercept, you already know that y equals 0. That's what it means to be the x-intercept, right? Right? So I take this equation, and which variable do I know right now? Y. So we have 3x plus 2 equals 0. And now we need to solve for what? X. So how do I solve for x? Subtract 2, right? We start with the easiest operations and we do the opposite of those. Okay, so we start with addition, multiplication, do the opposite. Right? So we get 3x equals negative 2. What do we do now? Divide by what? 3, good. So we have x equals negative 2/3, which is also 0.67. Does that make sense, guys? So that means my x-intercept occurs when x is negative 0.67 and y is 0. So our x-intercept is at 0. Oh, said that backwards. Sorry. Negative 0.67, comma 0. That is our x-intercept. Does that make sense, guys? Any questions? Any questions? No? Okay. Y-intercept. What point do we already? What value do we already know right now? What's x? 0. So using the same equation, we now put 0 in for x. So we do 3 times 0 plus 2 equals y. What's 3 times 0? 0. What's 0 plus 2? 5. What is it? 2. 2 equals y. Right? So what's our y-intercept? 0, 2. Does that make sense?
Yeah.
Yeah? Can we try to get our 3? Yeah, give the other 3 a shot. All right? Try them out. Turn the lights on. do B, same way you did A. If we're going to find the x-intercept, what do we plug in for y? If we're going to find the x-intercept, we plug in what for y? 0, right? So you end up with 3x equals 30. So you can divide, right? Okay. If we're going to find the y-intercept, what do you plug in for x? 0. So you end up with 5y equals. You end up with 5y equals 30, right? So you divide by 5. You get 6. You got long.